So our project is on COVID-19 visualizations. I'm Simran with my group Alvin, Allison, and Ashrita. So there are two problems we wanted to look at. The first was, can we model COVID-19 cases in various states using susceptibility rates? And the second was, how are small businesses being affected by COVID-19? So we were successful in creating our two models. For the first, we created a relatively accurate and functioning model to predict COVID-19 cases in different states. And for the second, we created visualizations demonstrating the impact COVID-19 has on small businesses. Given more time in the future, we would like to build a model for small businesses to determine if they should reopen or not, given features about that business and COVID-19 data.
Like Simran talked about, we focused on two main goals for this project. And to accomplish these goals, we had to get a lot of different data sets from a lot of different sources. So the first data set that we used was a county data abridged version that we found on GitHub. And the data was accumulated by the UC Berkeley Department of Statistics and EECS, and the team was led by Professor Bin Yu. The dataset contains demographic and health data on a county level for over 3,000 US counties. The second dataset that we used was a states dataset, and it contained COVID-19 related information, such as confirmed cases and deaths on a state level for all 50 United States states and various territories as well. This dataset was sourced using GitHub and was compiled by the Center for System Science and Engineering at Johns Hopkins University. This data was only used until July 17. The third dataset that we used was a time series dataset that contained confirmed cases per day on a county level for all counties in the United States and for various territories since the first recorded case in the United States. Finally, we used a table sourced from Wikipedia that contained all the ANSI codes for the US state and territories, which we used in our exploratory data analysis. And finally, for our business visualizations, which we'll cover in a bit, the small business data comes from Homebase, and Homebase is a tracking tool used by 100,000 local businesses and their hourly employees and consists of three metrics, namely the volume of hours worked by employees, the number of businesses open, and the number of employees working.
Our solution consists of two parts, which was published to a website via the Streamlit Python plugin. The first part is a series of visualizations on the small business dataset, and the second part is a predictive SIR model on the COVID dataset.
Awesome. Thank you, Allison. So I, along with the others, we worked a lot on the visualization aspect of this project. So this was sort of answering the second objective of our project to see how COVID-19 impacted small businesses. So for the first three graphs that we see here, after doing a lot of pre-processing, we basically grouped the home-based data by city. So we see some of the major cities in the United States on the y-axis for each of these graphs. And basically what's plotted as the frequency, or the x-axis, is the percentage, the three different metrics that we talked about before. So this one is employees working. We have to scroll up, Allison. We also have the hours worked and the locations open, just as Ashrita mentioned. And some general trends that we can see from these first three graphs is that some cities such as Hartford, San Jose, Detroit, New York, as we know, were highly affected. And we can see that through the data as they come across as the leaders in terms of the largest percent decrease in terms of the small business metrics. In terms of the least affected cities, cities such as San Antonio, Memphis, Indianapolis did quite well as their percentage decreases were quite small, indicating that they weren't affected as much. In addition to these three plots, we also have visualizations regarding how COVID-19 impacted small businesses by industry. So on the y-axis, we see the industries, and we can see, using the same metrics, that beauty and personal care and leisure and entertainment were some of the industries most impacted by COVID-19. Which makes sense because beauty and personal care is obviously a high touch industry that isn't safe to reopen, and leisure and entertainment is not essential. And then lastly, we also have some nice heat maps that we created. This was something that I was really that I really had fun putting together. And basically what we see here is each of these 3 metrics, this time plotted by intensity via state. So in terms of how to interpret the colors, the darker colors are actually sort of lower in terms of the impact that COVID-19 had on those businesses, while the lighter colors indicate that those states had a big impact in terms of their local businesses. So yeah, I hope you all enjoyed the visualizations, and Ashrita will talk a little bit more about the modeling of COVID-19 cases.
Thank you, Alvin. So our SIR model that we briefly talked about earlier focuses on 3 major terms, for instance. And so these 3 terms are susceptible, which is the S in the SIR, and the I is for infected, and the R is for recovery rate. So here, as we can see on our website, we have a marker for susceptible, how susceptible is your state, and susceptibility relates to how many people, say given out of like 100 people, for example, how many of these people are susceptible to COVID-19? So for example, how many people are likely to get the disease from other people. So we focused on a lot of different states, but for the sake of this presentation, we'll talk about California and New York, 2 states that were on the lookout during the pandemic. So for California, as you can see, with a susceptible rate of 30 out of 60 people, so about 50% susceptible rate, we can see that the predictive curve using the SIR model and the actual number of cases in California since lockdown are pretty accurate. So in this case, the actual number of cases represents the orange line, and the predicted represents the blue line. If we change our susceptible rate to 10 out of 60, we can see as the graph changes, we can see that the model itself changes by a bit, and we can see that the model is still pretty good in predicting the number of cases, but it's not super accurate as it was before. And if we raise the susceptible rate to 60 out of 60 people, we can see that once again, the graph changed drastically. And this is because if we had a 60 out of 60 susceptible rate, then the lines would obviously change accordingly because more people are susceptible to the disease. Besides California, we also focused on New York. So Allison, if you could change to New York. Yeah, so for New York, the trends are actually different than California. And this could be because when the pandemic started, New York had a huge surge in cases, namely because the state was small and there was a lot of people and there were a huge number of cases for corona. And so if we have a 60 out of 60 susceptible rate for New York, our model doesn't do a perfect job of predicting the cases. As you can see, for the early days since lockdown, our model underestimates the actual number of cases. And as the lockdown increases, so after like 100 days in lockdown, our actual model is actually below our predicted. So our SIR model overestimates the number of cases. If we change our susceptible rate to 30 out of 60, so about around 50%, our model gets a little better, but the model still underestimates for certain days since lockdown and overestimates for certain days since lockdown. And if we change our susceptible rate to 0 out of 60, we can see something really interesting. And that part is that the predicted number of cases for New York, if with a susceptible rate of 0 and 60, is actually really, really low. It's like close to 0. And this namely is because if there's no one who's susceptible to the disease, then no one in that state will get that disease in the upcoming days in the future. So that's why there's a 0 flat line for the number of cases predicted with the 0 susceptible rate.
Awesome. Thank you, Ashrita. And just to wrap up our presentation, by noting the impact that hopefully our model and our visualizations could have, is that we accomplished our goals of building a model to predict new COVID-19 cases and have visualizations that demonstrate the impact of COVID-19 on local businesses. And in terms of how we want to use this model, we expect it to be used as a tool for everyday people just like you and me to further understand how COVID-19 is evolving in people's respective states. And we hope that since our tool is easy to use and that there's a simple drop down and that it's interactive, people will have fun using it, and that they'll see sort of the trend of COVID-19 based off data and where that could be, what that could mean for the state. And we hope that these projections plus the ease of the tool encourage people to take preventative measures after they see that COVID-19 obviously is a deadly disease and is continuing to rise in many locations, that they social distance, that they wash their hands, and that they wear face masks. Also, in terms of some future applications that we brainstormed, Simran mentioned one in which we'd like to take a look about how we could take our model and take it to the individual business level to predict whether or not a business should reopen, given indicators specific to that business in COVID-19 data. In addition, we're also interested in exploring the different locations, like mentioned before in our visualizations, in combination with economic data such as unemployment claims, consumer spending, etc., to determine the economic resilience of each of different counties in the United States and see if we can predict that. Yeah, so those are some future applications, so stay on the lookout for that. And yeah, we hope you enjoyed our presentation. Thank you.